Hello, welcome to our senior project presentation. This is a combined approach to emotion recognition. We are the Mood Meter Maestros. I am Andres Martinez, and I'm the project manager.
I'm Manuel Nunez, the Scrum Master.
I'm Jonathan Mesa, the front and back end developer.
On to part one, project overview.
So let's simplify how we understand emotions. Usually we just look at words, which only gives us a basic good or bad vibe, but this misses the full picture. Emotions are more than just words. They're about how we say things, our facial expressions, and our body language. By focusing on these, we can get a real sense of someone's feelings.
So our solution to this is by building a multimodal model that will combine the modalities of the faces of the speaker and the audio that they speak. And so this will involve several convolutional neural networks that will combine into one fusion network, then that will deliver the final verdict. And it will classify their emotion as either anger, happiness, disgust, surprise, calmness, fear, sadness, and neutrality.
Now, beyond the 8 emotions mentioned by Mesa, we also aim to decipher a level of emotional complexity as far as a user's expression goes. We do this using Plutchik's wheel, which is a model developed by Robert Plutchik, a renowned American psychologist, which explains the way in which 8 basic emotions, the 8 emotions that we happen to be investigating, combine to create more complex emotional expressions. For example, a fearful face with a tone of surprise can be interpreted as a complex emotion of being alarmed. So we aim to combine our models such that we can look past basic emotions and explore a layer of complexity. Onto sourcing our data, we source both of our data sets from Kaggle. Both of our models will be trained using a supervised learning approach. So we needed a data set that was human annotated, that is, that was labeled with its corresponding emotion. It took us a while to find these data sets, but we were ultimately able to find them, as I said before, on Kaggle. And below you can see images of the 2 data sets that we'll be using for our project to train our models. Part 2, project design. I'll get us started with our system architecture. So the concept is rather simple. We want to build a system where a user can provide input. That input can be divided into both an audio context and a visual context, and both of these contexts can then be fed into their respective models for emotional classification, for these classifications to ultimately be combined into a more complex emotion deduction, let's call it, and for that deduction to be sent back to the user to show them the emotions that they've been expressing according to our models. We'll use Python for its versatility and ease of use, and within Python, we'll use the PyTorch package for deep learning, Librosa for audio analysis, and OpenCV for visual presentation analysis. A diagram of our system architecture can be seen in this image to the left or to the right, sorry. AWS, Amazon Web Services, is the cloud platform that we'll use to host our application. We can see the client up top in red, feeding data into the front end, which can be divided, as I mentioned before, into both auditory and visual data. This data is then sent to the backend, where a router routes the corresponding data to their corresponding models, which can either be the audio classification model or the visual classification model. We can also see how both of these models can connect back and forth with the data that they use to be trained, be that audio data or visual data, and how their classifications are ultimately joined and sent back to the router, which connects back with the front end and shows the user the ultimate emotion classification of both complex emotions and the basic emotions which have constructed it.
So like I mentioned before, our solution is a multimodal neural network. This will work with 2 convolutional neural networks, one that analyzes the screenshots of the speaker's faces and the MEL spectrograms of their audio that they say. And this will be put into a fusion network that will deliver the final verdict as to what their emotional classification is. And while this image roughly describes how our model is going to look, we are, of course, going to have to tweak things like the model hyperparameters, the hidden layers, and the optimizer function to ensure that our model is able to deliver the best result.
So for our user interface design, let's get straight to it. Our mood meter is all about simplicity and clarity. You start recording with just a click. What do you get after? A straightforward graph that tracks your emotional journey over time with precise percentages. But here's the kicker. It doesn't just show basic emotions like happiness or anger. It actually delves deeper, mapping out complex emotions, those that are a mix of the basics.
On to part 3, project progress. I'll first present the tasks that we've already completed. Data sourcing is the first task we completed. This entailed finding the data as well as downloading the data and making sure we could parse different files and identify which samples of data pertain to which emotional label. EDA, exploratory data analysis, looked into the variations found within our data as well as distributions to make sure that these statistical measures represented data sets that were ready for model training, such that we wouldn't have model bias or anything of the sort. The user data input program has also been implemented. This is a program which records the user and is able to save both an audio file of what they've said, as well as snippets, screenshots, let's call them, of their face for these images to be interpreted by the facial expression model.
And for feature extraction, we're basically at 30%, and we're like deep into analyzing audio data, plotting it, and figuring out the best ways to analyze it. And this milestone will be hit on February 23rd. Next, model implementations. We're 20% there. We're understanding the architecture, what goes in and what comes out. And plus, we're testing different models, seeing which one is perfect in terms of accuracy. And this will be hit on February 30th.
A few examples of the code we've implemented. To the left, we can see our user input program, as well as a snippet of my face that it recognized when I submitted my recording to the program. To the right, we can see an example of what our facial data looks like. And down under, we can see the distribution of emotional labels for the facial expression data, with happiness in this case being an outlier, but we'll make sure to trim that later on to make sure that that is evenly distributed.
So our next tasks that we aim to complete are the full UI implementation. This involves turning our Figma prototype into actual React code. And there are tools that will assist us in doing this that are free and anyone can use them, and we'll be using them as readily available. Model training, so actually like fitting the data to the model and tweaking it to ensure that we can ensure the highest possible accuracy, and figuring out what cloud hosting services that we need to host our full application.
So on to part 4, individual responsibilities.
So my responsibilities are basically to use the Python web framework to link the backend to the front end. And I'm also in charge of speech acoustics model architecture.
I'm primarily in charge of feature extraction for now. That is assessing both audio and facial expression data to see what features are best suited for input for both models. I'm also in charge of the user input program, which I spoke about beforehand, and the facial expression model, both as far as its architecture goes and its training method.
So I will be working on the data preprocessing, and I will be assisting on this with the speech acoustic model architecture. Furthermore, I'll be doing research into which AWS services we will need to host our full application once it's complete.
Thank you very much. This is our presentation 1 for our senior project.